All right, so you all got this sheet that has the 3 examples on it. And so that's what we're going to do just so you get used to how to do them. Maybe on the top you might want to write, maybe open the pen. You might want to write your equations. V av equals delta d over delta t. A equals Vf minus Vi over delta t. And then our 2 new ones, I don't usually write down the other average one. Delta d is equal to Vi delta t, 1/2 A delta t squared. And then our other new one, Vf squared equals Vi squared plus 2A delta d. Now, one way to remember these is every time you write them down, say them to yourself, say them out loud. Except if it's on a test, maybe don't say it out loud. But because the more you say them out loud as you write them, the quicker they'll go in your long-term memory. Okay, so example 1. An airplane is flying 80 meters per second with an acceleration of 2 meters per second squared. What is the distance traveled in 10 seconds? So it's initially flying 80 meters per second. That's your VI. Acceleration is 2 meters per second squared. And then it says it travels for 10 seconds. And it wants to know what's the distance traveled, what's delta d. And then it also wants to know what's the final velocity, Vf. Okay, so you look at your givens and you say, I have a Vi and a delta t, and I want a delta d. So which of these 4 equations can I use to help me solve that? Well, this one here, a delta d is equal to Vi delta t plus 1/2 A delta t squared, has these first 4 things in it. So let's use that one. So once you write down your givens and what you're looking for, then you write the equation. Delta d is equal to Vi delta t, 1/2 A delta t squared. Don't have to rearrange it, so I can fill my numbers with their units in. So delta d equals Vi 80 meters per second, delta t 10 seconds, plus 1/2 A 2 meters per second squared, t 10 seconds squared. All right, so delta d equals 80 times 10 is 800. And then you're going to do meters per second times seconds, so the seconds will cancel and just leave you meters. Plus 1/2 of 2 is about 1. And the only thing that gets squared here is just the 10. So 10 squared is 100, times 2 is 200, half of which is 100. And then meters per second squared times seconds squared, they'll cancel and just leave you meters, which is good, because then you can add it to the 800. And obviously delta d is measured in meters. So how far did it travel? 900 meters. So that's the first part of the question. The second part of the question says, what's the Vf? So now you have a couple of options. You could use A equals Vf minus Vi over delta t, because they gave you A, Vf, and delta t. Or you could use your new equation, Vf squared equals Vi squared plus 2A delta d. Doesn't matter at all which one you use. I'm just going to use the new equation just so you can see it. So Vf squared equals Vi squared plus 2A delta d. So Vf squared equals Vi was 80 meters per second squared plus 2A was 2 meters per second squared. And delta d was 900 meters. So 80 squared is 6400, and that'll be meters squared per second squared. 9 times 4 is 36 with 2 zeros. Meters per second squared times meters will be meters squared per second squared. So Vf squared will equal this number, and then take the square root, and I think you get 100. Vf equals 100 meters per second, and example 1 is done. Okay, so it's just that easy. Let's look at example 2. A plane increases its speed uniformly from rest and reaches a speed of 50 meters per second in 10 seconds. So from rest tells us Vi is 0. Reaches a speed, Vf, of 50 meters per second in 10 seconds. Delta t is 10 seconds. What is the object's acceleration? So we're looking for A. And how far did it travel in this time? We're looking for delta D. So you go back up and you look at your equations and you say, what equation can I use that has a VF, a VI, and a delta T in it and will let me get A? And hopefully you pick this one, A equals VF minus VI over delta T. So write it down. A equals VF minus VI over delta T. Don't have to rearrange it. We're looking for A. VF was 50 meters per second. VI was 0 because it said rest. And the time was 10 seconds. So 50 over 10 is going to be 5 meters per second over seconds is the same as meters per second times, remember dividing by a fraction is like multiplying by the reciprocal, so times 1 over seconds, and it's going to give us meters per second squared. So A is 5 meters per second squared. Okay, B wants to know what is the distance traveled. So now we go back up here and we say, which equation can we use to find distance traveled? I have a delta D, I have a delta T, I have an A, and really I could use either of these two. I'd probably be tempted to go with the delta D equals VI delta T plus 1/2 A delta T squared one, because then I don't have to rearrange it. This one I would have to rearrange to get the D by itself. So let's go with the one we don't have to rearrange here. And so write it down. Delta D is equal to VI delta T, 1/2 A delta T squared. VI is 0, and if VI is 0, then this whole term will be 0, right? Because 0 times delta T will still be 0, so this whole term disappears. And you could put a line through it just like that with a 0 here. And so that'll be equal to 1/2. The A you just found was 5 meters per second squared. And the time they told us was 10 seconds. So square your 10, that makes 100, times 5 is 500, take half, it'll be 250. Look at the units again, meters per second squared times seconds squared, so the second squared will cancel, and you'll be left with meters. Done. These equations are kind of fun, aren't they? All right, one more to do. Calculate the stopping distance. So you're looking for delta D, stopping. It says distance, but the fact that it says stopping means that your VF must be going to be 0 because it's stopping. Calculate the stopping distance of a car going 4 meters per second. So VI is 4 meters per second. And when the driver applies the brakes to slow down to a stop at a rate of 10 meters, and there's a misprint there, that should be per second squared, and it's a negative because they're slowing down. So A is negative 10 meters per second squared. Okay? So what equation do we have that has a delta D, a VF, a VI, and an A in it? So go back up top here and take a look. We don't have time. And the only one up here that doesn't have time is this fourth one. Okay? So you're going to use VF squared is equal to VI squared plus 2A delta D. And we want delta D, so we're going to have to rearrange for it. We want to get the delta D alone, so first get the whole term with delta D alone. Take the VI over. So VF squared minus VI squared equals 2A delta D. And then to get the delta D alone, divide by 2A. And so we'll be left with delta D is equal to VF squared minus VI squared over 2A. So now we fill our numbers in. It's stopping. So VF is just 0. Minus, it was initially going 4 meters per second. And that gets squared. And the acceleration was negative 10. Now, notice this minus sign is not part of the 4 meters per second. So when you square this, the negative stays and you get 16 meters squared per second squared on the top. And on the bottom, you get negative 20 meters per second squared. So the two negatives are going to cancel out, become a positive. I think I'm solving for D, yeah. 16 over 20